on.
Hello everyone. Sorry I was late. So do you have any problems from the last classes? Any question or doubts? Please respond if whether you have doubts or not, or I will start today's class. Can everybody hear me clearly? I am not understanding whether you can hear me or not, so please respond by yes or no. Please respond whether you can hear me or not.
Yes, ma'am. Yes, ma'am.
Okay. So I will start today's class. I told that in today's class we are going to discuss about laser.
Yes, ma'am.
Can you see the presentation or the PDF?
Yes, ma'am.
Okay, so I start with laser. We did some brief introduction about laser in one class, na? So it is basically light amplification by stimulated emission of radiation. You already know what a laser is, and we have already discussed about the properties of laser, like what are the characteristics. It had four characteristics: highly coherent, high intensity, high directionality, and high monochromaticity. Monochromaticity means it is of single wavelength. The wavelength spread in the beam is very small compared to ordinary light. Highly directionality means it was the it propagates along a particular direction with a very little divergence in the beam. That means if you are using a laser light and you throw it to the moon, if the laser beam has a diameter of 1 centimeter here in Earth, it will have a diameter of the order 5 kilometers or a few kilometers in the moon. So basically the divergence in the beam is very small. It does not spread it goes in one direction. Likewise, we have coherence. The laser beam has to be highly coherent. That means all the photons must have the same phase or the same phase difference. As a result, if they have a zero phase difference, they will produce constructive interference always, and if all the beams they produce constructive interference, the intensity becomes very high. This you already know from grating diffraction. Grating diffraction में क्या होता था? We had n number of slits. उसको हम imagine कर लेते थे कि we have n number of beams and they interfere with each other, and the intensity, it was proportional to n square for the maxima. So when constructive interference occurred, the intensity becomes proportional to n square, where n was the number of slits, or you can say the number of sources. Similarly, for laser light, if there are a lot of beams, if we have a suppose n number of rays in a beam, then the intensity will be n square. So laser has these four basic characteristics, and as a result it is very powerful and capable of doing many things which an ordinary light cannot do. So knowing laser, we need to know about these few things, how the laser action works. Among them, absorption, spontaneous emission, stimulated emission. These are the things when photon interacts with matter and how it interacts with matter. Now we are going to the details of these things. We will discuss about the population inversion and pumping, all of them in details. First, we come to absorption. What happens in absorption? The atoms, they generally have discrete energy levels. Now, let us have an atom which have a discrete energy level. The difference between the two levels is given by E. Now, if a photon of particular frequency nu comes in, where h nu equals to E, then the atom at the ground state, it absorbs the photon and goes to the excited state. This process is known as absorption or stimulated absorption. Why stimulated? Because it depends on the frequency of the externally applied photon. So here the lower level is the E1 level, the upper level is the E2 level, and E is the energy difference, h nu. Now, so here we have written hf, where f gives you the frequency instead of nu. So h nu is E2 minus E1. Now, how much the absorption will take place or the rate of absorption, it will depend on two parameters. First, the energy density, which is given by UF, or in my notes, I think it is written as U function of nu, and N1, where N1 is the number of atoms present in the ground state. क्योंकि क्या होगा, ग्राउंड स्टेट में जितना ज्यादा एटम रहेगा उतना ही ज्यादा एब्सॉर्प्शन रेट बढ़ जाएगा. So P12 is proportional to N1. अच्छा, ये किसने किया है भाई? Okay. So P12 is proportional to N1 into U function of frequency F, or P12 is equal to N1 UF, where B12, this term is known as Einstein's coefficient of stimulated absorption. It is a proportionality constant. Okay. Now, as absorption is always stimulated, क्योंकि वो हमेशा बाहर की frequency के ऊपर depend करेगा, so we will call it always stimulated, and we denote B by स्टिमुलेटेड। बाद में जब हम एमिशन पढ़ेंगे, एमिशन दो तरीके का होता है, स्टिमुलेटेड और स्पॉन्टेनियस। स्टिमुलेटेड के लिए हमेशा हम लोग बी यूज करने वाले हैं और स्पॉन्टेनियस के लिए ए यूज करने वाले हैं। तो P12 is equal to B12 N1 UF. Now we come to emission. Emission मैंने कहा कि दो प्रकार के होते हैं, one is the spontaneous one, another is the stimulated one. Spontaneous emission में क्या होता है? If the atom is in the excited state, it cannot stay in the excited state for a long time because the lifetime of the excited state is very small. It is of the order of 10 to the power minus 8 seconds. So the atom cannot stay in the excited state for a long time. So it eventually goes back to the ground state by releasing some amount of energy, and the energy is equal to okay, h nu equal to E2 minus E1, where nu is the frequency of the emitted photon. So this process happens spontaneously. So this is known as spontaneous emission. Now look at the factors. On which factor it will depend? First of all, it will not depend on the external energy, क्योंकि external energy कोई भी हो, spontaneous emission हमेशा हो सकता है. But it will depend on the number of atoms present in the excited state. ऊपर वाले एक्साइटेड स्टेट में, मतलब E2 लेवल में जितना ज्यादा नंबर ऑफ एटम्स प्रेजेंट होगा, स्टिमुलेटेड एमिशन होने का चांसेस उतना ज्यादा है. सो the transition depends on the number of atoms in the excited state N2, and we write P12 spontaneous. पिछला वाला क्या था एक बार देख लेते हैं. It should be P21 actually. Okay, so this was P12 क्योंकि transition from level 1 to level 2. Now here I think we have a printing mistake. So it will be P21 spontaneous, transition from level 2 to level 1. P21 will be proportional to N2, and it will be equal to A21 into N2, where A21 is called Einstein's coefficient for spontaneous emission. As I said already earlier, that we will denote the spontaneous things by A and the stimulated constants by B. So P21 spontaneous, correction here, P21 spontaneous is proportional to N2, or it is equal to A21 N2. Now we have another thing called the stimulated emission, जिससे लेजर का नाम आता है. So what happens in stimulated emission? In the stimulated emission, the atom is already in the excited state. Now, if a photon of particular frequency nu, so that its energy E becomes h nu, which is equal to E2 minus E1, falls on the excited atom, then it interacts with the atom, and the atom gets de-excited and it goes to the ground state by emitting two photons. One photon was the incident photon, this one, and the second photon, this is due to the energy transfer or the transfer of the atom from the excited state to the ground state. So as a result, one photon falls on an excited atom, the atom goes to the ground state, and two photons are released. The main interesting thing here is that these two photons, they have same frequency, same amplitude, same phase. As a result, when they come out of the system, we get a constructive interference of these two photons. तो energy double हो जाता है actually. So this is known as stimulated emission. Now, on which factor is the stimulated emission dependent? First of all, the incident energy, तो energy density के ऊपर depend करेगा. And second is the number of atoms present in the excited state or the E2 level. So it will depend on two things, UF and N2. So here it will again be P21 stimulated proportional to UF into N2, or P21 is equal to B21 into UF, where B21 is the proportionality constant known as the Einstein's coefficient for stimulated emission. Okay, so we have got P12 and P21 stimulated, P21 spontaneous. So as I said, one photon of energy HF stimulates two photons of energy HF in same phase and direction. So we get coherent light amplification of radiation by stimulated emission. Now we are going to the population inversion a bit later. Before that, we need to know the relation between Einstein's A and B coefficient, or the relation between the spontaneous and stimulated emissions. So we already got the rates of emission and absorption. So in thermal equilibrium, the number of emission will be equal to the number of absorption. So in thermal equilibrium, we can write the number of absorption was B12N1UF. This will be equal to the number of emission. The first one is for the spontaneous emission, A21N2, and the second one is for the stimulated emission, B21N2UF. Now from here we will find a formula for UF. So we get UF equals to this one, A21N2 divided by B12N1 minus B21N2. अभी हम यहाँ से so from here we get the formula for UF equals to A21 by B21 divided by B12N1 by B21N2 minus 1. ये तुम अगर खुद करोगे तो you will get the relation. थोड़ा इधर उधर करना होगा. Now, what is the relation of N1 and N2? To know the relation of N1 and N2, we will use the Boltzmann distribution law, which states that N1 equal to N0 into e to the power minus E1 by KT, where E1 is the energy of that state. So E1 energy वाले कोई भी state में the number of atoms is given by this relation. Similarly, N2 is equal to N0 e to the power minus E2 by KT. तो यहाँ से N1 by N2 आता है e to the power E2 minus E1 by KT, where E2 minus E1 is again H nu. So we can write N1 by N2 is equal to, h nu by e to the power h nu by kt और e to the power h f by kt. यहाँ पे f यूज किया गया है न्यू की जगह, तो we will put it in the equation. So uf is given by a21 by b21 divided by b12 by b21 e to the power hf by kt minus 1. Now, according to Planck's radiation formula, you have now already derived the Planck's radiation formula in quantum mechanics. So you know the relation u nu was 8 pi h nu cube by c cube 1 by e to the power h nu by kt minus 1. So here we have used f. So uf is given by this relation. Now we will compare equation 7 with equation 8. Look here, we have a h nu by hf by kt term here in the power of e. So comparing this equation number 7 with equation number 8, we get